Mhm.
So the main goal is today's discussion is focused more on engineering aspect of the house, what research the teams
Mhm.
did, lessons learned, and advice to future decathletes. So we can maybe do a quick round of introduction of our background and the position we were in during the project, and then we'll start with few questions. So
Okay.
yeah, so I'll go. So hi, I'm Mayur. I I was a project manager of the team, and my major was in architecture. Anyone
Okay.
else would like to go next?
Hi everyone, my name I'm the photovoltaics and electrical team lead, and I'm majoring in material science and engineering.
Hey everyone, I'm Chris. I was the construction management team lead in 2019 and a little bit into 2020, and then I was the operations lead until September, October of 2020.
Okay, my turn. So, hi everyone. I'm Housen. I'm the HVAC team lead of ISD. My major is construction management. Yeah, that's me.
Okay, my name is Lorraine. I come in representation from Team Chile and Casa Phoenix 2.0, the Universidad Técnica Federico Santa Maria. Thank you for your invitation.
No problem. Thanks a lot, everyone, for joining this call. So the first question I have is, what were some uh, design challenges you faced for your role, like comparison of few systems and why you chose the system we have or the construction methodology we chose with. So we'll start with Hossein.
No problem. Okay, so for HVAC design, wow. So the HVAC design, like the design from the scratch, it was actually began in the year like early 2019, I believe. It's or late 2018. Is that right? Yeah,
Mhm.
probably around that time, like the first team lead, John. He's in charge of the whole design. But I do learn about some stuff like the train of thoughts of how we come can to like end up with using this ventilation plus duct mini split design. So the primary concern in this project in HVAC system is to be able to uh, like expand the system in the future. Say at the beginning, our design is like three modules, and we want them to be able to be like transported to somewhere else, and we can uh, like uh, build the house easily, connect all the system. So that's the prime reason why we are using the duct system, because we only need to put one main unit, air handling unit, at one module. And if we want to move the module, we only need to disconnect the ducts between each modules. Uh, and also, like our system, ventilation system is connected, seamlessly connected to the mini split system. So, which means they're using exactly the same duct system. That makes things even easier because we only need to handle one duct system if we are going to expand or like reduce the number of module. That's our primary concern. And the secondary concern is uh, about the like sustainability. Say at first we are we were thinking about using electrical heating, which is not that sustainable and not that efficient compared with a heat pump system. So a heat pump system, say if you consume 1 kilowatt hours energy, you can actually bring 3 kilowatt hour of heat energy from outside into the room, into the house. This is extremely efficient in the winter time. And considering Illinois has kind of a terrible winter, this is really helpful. So it's like the two primary concerns in our design process. Yeah.
I see. And just to give some background context, we have like the modular design where one can start with 600 square feet of module and then they can add more modules when they need it. So the HVAC system had the challenge that how can the system adapt to that kind of architectural and structural requirements. And yeah, and Hossein explained very well the reason mini split makes sense for those scenario. And just to give some additional information, when we were designing that system for the cold form steel and wooden module, the whole mini split ducts were passing from one module to another module in above the ceiling, and we had access panels when two modules are connected that the duct can be easily connected at that junction. So that's why it makes sense. Now, I would like to ask Chris about when you guys were working, what were the construction companies you contacted, the methodology, and the whole procurement thing for this kind of design? How was the process?
Do you mean procurement of materials?
Yeah.
So first, to find contractors, we started with connections we knew in the industry. And then from there, we would move on to cold calling contractors. And then based on their interest, we would then move forward and try to get a cost estimate from the contractors. And then, well, when we received the cost estimates from contractors, there was a lot of variation because the house has a lot of unique systems, unique materials. So, and some contractors were specifically building contractors, not necessarily residential. So it was kind of a balancing act trying to figure out which contractor was best. And then for procurement, we really just kind of used the schedule that we received from the contractors, and we kind of worked backwards based on the shipping time. And we can determine, or from the date that it's needed on site, we can determine exactly when we need that material ordered by for it to get on site when it's needed. So as far as like lessons learned related to design, I think it was, I just wanted to stress the importance of getting our drawings into the hands of the contractors as early as possible so they can look at it and make adjustments accordingly, because small changes that we think might be small could actually change the construction method completely. So
Yeah, and I would also like to know, like, what were some strategies which worked out for the CM team, because you guys had to coordinate for drawings with other disciplines for BOQ. So what would be your advice to get better at communication?
I think Well, there was definitely a lot of room for improvement for the way we did it because, it was our first time doing anything like that. But I think what seemed to work well for us was having one person responsible for maintaining and organizing the BOQ. For example, checking quantities with each team, checking to make sure they have all their materials updated in the BOQ. That was just a lot easier if it was run through a single person rather than multiple people working on it, because it just creates more communication gaps and makes things a little more complicated.
Got it. Now I'd like to ask Nitya, what were like, so you joined in 2020, right? When there was some design aspect done by the previous team lead. What were the challenges you faced when to understand the work they did, what thing worked out, and you overcame a lot of issues with sponsorship and design integration. So can you tell us that journey and story?
Right, sure. So, like when I joined, like the design was pretty much set by like the previous lead. It was like the PV system. It was just like the whole thing was supposed to be like a Solar Edge system, and we did have Solar Edge was our sponsor already at that moment in time. But the thing is that we also needed like a battery storage, and at that point, our team were looking at like battery storage sponsorship. But like the previous team wasn't really aware of a specific type of battery that was compatible with the system. So we just, we emailed like all these different companies and we got a sponsor, which was Big Battery. And then, like we had a lot of communication issues with our sponsors. So like for a couple of months, they didn't respond to us. And we also, I guess, like we didn't really see like why we needed to, I guess, like push for it early on because we felt like we still had time. But like that was like a lesson learned because, like we had to discuss with our sponsors like our design, and we had to make sure like everything was compatible and all of that. So like towards the end, when the sponsors finally like responded to us, they said like, oh, like this battery wouldn't work with our system because of like the voltage difference. Like Solar Edge is like a high voltage system, and like the battery was like a very low voltage battery. And it was very late when we figured that out, and we really did want to keep Big Battery in as well because there was like a like it was repurposed from like electric vehicles, so like we wanted to keep that battery because that like compared to like it's better compared to like other batteries in the market. So like we try to figure out, like we had like a month or 3 weeks to try to figure everything out, try to figure out a whole new system design. And if like it's either we figure out a new system design with all the components we already had, or find whole new sponsors. And so we had to figure that whole thing out. And in the end, we did come up with a new system design, but we also had to find new sponsor, like because we had like an additional component, and thankfully we also did do that. So yeah, like right in the nick of time, we found a new design that worked. It was a bit experimental, so we weren't sure if it was going to work perfectly, but it kind of did. It just like during installation, there was also like a lot of, because it's not like there are differences between like a conventional system on the market and an unconventional system on the market. So like ours was very unconventional. Solar installers weren't familiar with that system, but still like I still felt like I liked our system because it was unconventional. There's like a lot of like effort that we put into it, and a lot of different parts that we managed to integrate that we didn't really think we could. So yeah, like the lesson learned from that is like, talking to sponsors like way early on. They are like all of our sponsors, they do take some time to respond, but you really have to like give them a call, especially if they don't see the urgency as well. because like they see like, you know, there's a lot of many months left and they're like, no, we don't really need to talk to them right now. And because like that's very apparent, because whenever you like put urgent in the email, or like if you say like, oh, there's like 2 weeks, 1 week left, and then they start responding very fast. So like you have to show them there is a sense of urgency to make sure that they respond. And yeah, just better communication with the previous team as well to kind of sort things out. But yeah.
Got it. And I remember like there were some challenges during construction of the PV and electrical part. Uh, can you like share some advice how one can do better for related to construction aspect of the systems, and also some brief overview about what were the software you use for deciding the angle and energy computation?
Right. So in terms of the construction part, because we had very little time before the construction began, we couldn't really discuss with the installers beforehand. So I think it'd be good if if you had some time, and with that time you discuss with the installers and you talk to like, so let's just say you're using Solar Edge components, then you talk to them and like make sure like all your design, like if that would, like you wouldn't be running into any issues. So like all of this discussion like beforehand, like we didn't really have, like every discussion was done like as the construction was going on, because like lack of time. But yeah, like if things were done beforehand, it'd be good. And software, so we used, I guess, like the most helpful one for us was eGauge, which was actually provided by Solar Decathlon. So I think, I'm not sure if like eGauge is used in every year of the competition, but if it's not, then like I'd like highly suggest like future decathletes to use that as well, because it gives a very, very comprehensive result, like as in like where, like how much the production is, a daily production, how much you use, how much each like service panel uses. It's very detailed. So I think like the eGauge was very helpful to us, and that we use that to monitor the energy production and consumption for the competition. And one more thing is that for like the energy performance sub contest, so like there were like a couple of sub contests, like the rest was all like it was pretty easy to get full points, but like the hardest one was like the Her score. So I think regarding the Her score, like teams should use the I guess like energy analysis software very early on. I feel like using it later on doesn't help much. The reason why you should use it early on in the design process, because it helps you, like if you need to make any changes, you can, if it's early on in the design process. If it's late, then you're just like gonna have regrets instead of being able to change anything. So yeah, I think using energy analysis softwares early on is very, very crucial.
I see. Cool. Now I would like to ask Lauren about what construction challenges or design challenges you faced in your project.
Well, our project answered the question, the Haberkens, why do people change their house? The team addressed this is so from our Chilean perspective, by identifying various factors. For example, the need for identity, the change in lifestyle, the change on family profile, the recurrent natural catastrophes, earthquake, tsunamis, a volcano, for example, and the new technological possibilities. We talk originally an existing housing problem in Santiago to inform the design, the ground work on the proposal. For example, in Chile are facing gentrification, poor gentrification, the social inequality and contrast between communities are evident in terms of connectivity and service, causing low-income families to migrate to the neighborhood with a lower quality of life in order to escape the rising cost of housing. And in this scenario, a group of inhabitants from Ñuñoa, Santiago de Chile, inspired the various versions of Casa Phoenix 2.0, in this time, metamorphosis in the beginning. Where the premise was, we don't want to stop living in the place that saw us grow. This concept is conceived as a response to This Is So, which sees housing as a process that adjusts the family life cycle and change of profile family, resting high flexibility by continuous architecture transformability from an early stage of design. So, which portrays the upper and upper middle income sector. And so is born our prototype. And we think the flexible design approach begins with a basic set of units, but the structural grid with the answer to the disaster natural mentioned. Adaptability is an adaptability for the change of life of the families when born a boy, a son, and then this son go to the university, and the family was there alone, and so the most important is the engineering, because it's a novel future in the robot assistant carpentry. The post and beams structural system from a medio-rise building is based on engineering wood manufacturing with robotics processes, being this innovation for our country. It's a mix. The reality family, the construction, the natural disaster. It's a mix. And then, for example, when we build wood with wooden in Chile is industrially manufactured, composed with wooden beams with robotical carved out joints. Is a precision and high replicable approach of robotic manufacturing. It's opportunities for more fast process, you know, because we have a lot our disaster that we are working is a disaster of 245 families, and it's the reconstruction. And so, well, I don't know, we built so a mitigation and irrigation firefighting system too. It's like, it's a mix, a problem. A lot of factors we build that with engineering.
I see. Yeah, I even like I saw yesterday you show pictures of how like a family is gonna live who was affected by the fire in the history. So it's in that context, using advanced building technology, using robotic fabrication, like your system in-house demonstrates a lot of innovative technologies. It's, and no, it's very resilient. So great job. Now,
Thank you.
mhm. I would like to ask Dusty about the unique plumbing aspect of this house. What was the driving force for Greywater design? How was your discussion with the officials and lessons learned and advice to future students? You're muted.
So it was. So yeah, what I've spent the last year doing, and obviously I wish it was more fruitful, but we've definitely learned a lot through this. So I think one of the main things is to decide that you want to do this from the get-go, and then get your heads together and determine the best way of going about it. I think one of the areas where we could have improved is determining a more clear checklist of things that we needed. We knew that the idea was good, that it's safe. We didn't understand really the amount of resistance that we would face. And kind of along that thread, I think having faculty that are dedicated towards this sort of idea, this project, will be really helpful. Obviously, we function very well as a student-led group, but I think for any particular projects that are kind of pushing the envelope, if you will, especially of building code in the state, you need somebody that carries a little weight. And I think as students, we could benefit from somebody with some letters after their name or some credentials. That is definitely an area where we suffered is really just resistance from the government and a lack of attention overall paid to what we were doing. That said, we did accomplish a dual plumbed system, so the home could at some point in the future adopt Greywater without having to redo all the plumbing in their house, which is a victory. Also, we've sort of pushed the state, I think, in the right direction, and I think this is an advantage of the Solar Decathlon project, is that we can kind of bring these things to the limelight, and I think that's really valuable. So I would really encourage people in the future to, especially with Greywater, because that's just something that I recognized, to really push for that, because that is how change happens, and I think that's really valuable.
I see. And is there anything you wish you would have done differently in the approach to get the codal provision for it?
I wish we would have gotten sort of a more concrete checklist from the government. So when we first talked with them, we had sort of we had a voice call with them, and they listed some things that they would want. And we also had a list in email, but it was not official by any means. So we compiled everything that we thought was sufficient, and we sent it their way. And then we got a response in 3 months, and a lot happens in Solar Decathlon in 3 months. 3 months later, we got a response asking for all these additional requirements. A lot more people got pulled into it. So again, starting early and getting a very clear direction from those in charge makes everybody more comfortable with the idea.
Got it. Now I would like to ask Key, like some of the lessons you learned in the simulation analysis you performed and advice to future students about learning those software or getting the most out of it.
I would say it is important that everyone kind of gets familiar to how to read the data. and have access to it if they want to. So like in any cases where if I'm not, because in the project I was focused mainly on the analysis, and a lot of times Nitya wants to look at it, and we had a class, like a semi class for an hour, where we talked about how to use BOP, and everyone is able to access the data and want to make some changes to it, and it's very easy to do that. So so I encourage everyone to at least learn the basics of it, so everyone can get familiar with it.
I see. Okay. And few things I would like to share from structure's point of view, where we did a pretty good job in identifying Thornton Tomasetti as our design professionals, and they were quite supportive when student got stuck in making like the design code compliant with all the calculations we shared with them. It was stamped by a structural engineer from TT. So it was a very high risk job for the team, and they spent a lot of time learning, doing analysis and doing hand calculations for the job. So I think the earlier involvement of contractor and a design professional, not only from like other disciplines, but also licensed professional, can avoid a lot of mistakes one could do in the early phases. Uh, the last question I have for everyone is uh, looking forward for the next team. Is there like, can you share one important lessons they want to do, or some analysis at the beginning of the project that, okay, talk to this people or do this software analysis first, and like one lesson everyone should take care, and one piece of advice for them?
Meyer, if I could start, kind of going off of what you said about making sure we get early involvement of engineers and particularly contractors. I think future teams could start from the very beginning, start talking to contractors, design professionals, and say, hey, we have a team. We're going to try and compete in the Solar Decathlon Challenge. And we can use the stuff from this year and say, hey, this is what we did last year. We're going to try and do, compete in this competition again. If we continue to succeed, like, do you want to participate? So we could start those conversations from the very beginning and start to get like informal confirmations from companies who would be interested in working with us. And then once we get to those later stages, we start really kind of hammering down and locking things in. Also, along with that is early involvement from the school. We had a lot of issues or a lot of challenges getting the university involved, and same with faculty, as Dusty was mentioning. That would be a huge help to future teams.
I see. Hossein, would you like to go next?
I don't have some very concrete recommendation or strategic recommendation, because the design for HVAC system of single-family housing is actually easy. I would say the only thing we, like as a HVAC team, we need to focus is to make sure the whole, like all the things are purchased and installed correctly, and talk with your sponsor, double check the design, and most importantly, be very familiar with the design, know every single detail about the advantages and possible shortcomings and so that you can like present it better in final presentation. Because actually this time, our team received lots of questions about the HVAC system, because at the design stage, actually all the stuff information about HVAC system are based on simulation. So they start questioning, and there's a tip for future like competition. So the competition actually like has the result for the comfort and environmental control sub contest really early. I think after the inauguration. Am I right? So you can get the result of that sub contest really early, which is real world data. And if it's showing some good sign, you can definitely use it as one of your evidence to prove that your system is outstanding or it's working well. Like real world data with simulation result. So that's I would say what people need to focus in the future competition about HVAC system.
I see. And you started from like a civil engineering background, and you learned about HVAC systems. So like any advice for people who are totally new to this area and wants to learn and get started?
Take all courses on heat spring building science series. Yeah.
Thanks. Nitya, would you like to share?
Yeah, so like I do agree like with your point earlier and Chris's point earlier of like getting involvement of like like experts early on. The thing is that we usually like get help later on because we get help from our sponsors and they're the one who like best understand our system because we're using their components. But like I think there are a lot of industry experts that can still help you out early on, even if like they're not like sponsoring like any equipments or anything. So like this industry experts, like you can just reach out to anyone and someone will be willing to help. Like we did have one like company, like a solar company that we reached out to. Like they didn't sponsor us, but they like uh, gave us their help. So I think that was really helpful. So that those are things that you can reach out for like early on in the design when you're in the process of designing the house. And then another thing is that regarding the simulation, I think because usually simulations has components from every different sub teams like architecture, structural, HVAC, water, and everything, right? So I think like every team should be familiar with energy simulation because usually it's just like one person doing it or like two people doing it because they're taking information from like what the other team already have, like the design that is already existing. But like if every team has someone who's familiar with the energy simulation, then they'll better understand how the decisions they make affect the load consumption of the house, and that can be really helpful, like what trade-offs you can make, because there are like a lot of little information in the energy simulation that you can find out. So I think that that's really helpful. Yeah.
I see. And one thing which I found could be a useful skill for everyone in the team is learning Revit to represent the design and generate drawings. So the team spends time on training and learning it well. It will help in future when there's a need to produce a lot of drawings.
Mm-hmm.
Cool. Lauren, would you like to share one piece of advice to the future team members?
Well, our university participated in Solar Decathlon 2014. And in these opportunities, we are part of the second team. I say that because start another student in the competence. But well, Casa Phoenix was made possible due to donations and sponsors. And And for Chiles, we removed the expensive renewable energy technologies such as PV panels, double panels window, and robot-assisted carpentry of glulium beams. We will rate a more competitive price. And even if we scale up the project, it is still does not reach financial feasibility. And in this case, it's very difficult think in these opportunities. Think about this because it's very difficult because Casa Phoenix 50% was built about a subsidy, 33% for the university, and the 15% the cost was about the rebates, the sponsors, and it's very difficult. We hope in the future will be a better situation in Chile with the subsidy, because it's very, the reality in Chile is very, very sad. In the subsidy is very poor. Not, it's enough, it's not enough the money for the construction. The forts are very, 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 very much. We had for example, the group continued with the following sponsor of the any companies, local authorities, but we don't know if they will help us or the future members of teams in future. But we are investigated new materials, new technologies. I hope so. These try to practice our knowledge or their knowledge in the future.
Mm-hmm. It's quite important that you mention about finance and feasibility, and I think Chris would agree on this. It's good to get like the full project cost as soon as possible, because at for a long period of time we were speculating the cost of concrete and the foundation, and uh, we had to make some decisions relate financially based on the total project cost. So it might be a good idea to identify the client as well as the total project cost. The sooner the better.
The foundation was a quarter of part of the presuppest, the money, the total money in the project. It's the fourth part. And then another part, the primary structure, the facade, or the insulation, for example.
Yeah, and I remember yesterday you were, I think Nina was sharing that many times once you start constructing, you find that some things are missing, or the sponsors send material which is not enough. So on site, you need to make decisions and change or buy something locally to get the project moving. So also be ready. Like you can do your best to make the BOQ accurate, but there might be few on site things. Even like we had one material which was delivered a bit damaged, so we had to make decision on uh, to replace that material and get the project moving. So I think having higher money on contingency is important, because there were so many costs which we didn't foresee, and since we were lucky to have some extra budget for the contingency. Otherwise, the budget which we had planned, we exceeded way more in our contingency funds.
Okay.
Yeah.
The situation of Chile in the past 2019, in October, sorry. It was a problem in Chile. And then in 2020, start January, February, and March, start the COVID in Chile. And some sponsor don't give us money. And we must to change some materials. It was very difficult. In a moment, we think it's not possible to build that, but we arrived then, and it's possible. We must change some material, but when the hope is present, all is possible.
Yeah, that's a really good point. I think we had one or two sponsor because of the COVID, they backed out, and so yeah, COVID posed another challenge to the sponsorship relationship. Like MOU helps, but if there are some things which they are persistent, we can't stop or change the sponsor. We had to move on. So, lastly, I would like to ask Dusty on any one particular piece of advice you would like to share with future team members.
I think, I mean, you guys have really hit the nail on the head here with sponsorship and just not being afraid to cold email people, cold call people. We were able to get a lot of our materials sponsored just through goodwill, essentially. And I also would, again, stress the opportunity of the Solar Decathlon competition to really push for innovation, especially in Illinois, where we have particular stringent building codes, within Greywater and outside of it. But I do believe that this is an opportunity to improve upon that, and the options are there and the resources are available.
Awesome. So we are almost reaching an hour mark. So I would just like final thoughts of conclusion and any question I didn't ask, but a particular thing you wanted to share for this lessons learned talk. So is there anything which you'd like to add?
One thing I just thought of that I think will provide us or future teams with better feedback on the design is when we're talking to engineers and design professionals, we should first develop a design or a layout and then present that to them. And instead of just saying, please review our design, we should ask them very specific things about the design. Like, hey, will, this diameter pipe work, in this location between, these two pieces of equipment, stuff like that. Because a lot of times when we would just send our design to people to review, they would be kind of confused and they would really just kind of say like, oh, what am I supposed to be doing here? Am I going to be looking through everything or just part of it? So I think developing a design first and not expecting them to do the design, and then asking them very specific questions about our design.
Yeah, that's a really important point.
I think kind of going along that line, there's a very particular language of drawings and just like language in general in the professional world that I think students were kind of out of touch with. So I think it would be valuable to have, faculty or professional just kind of oversee the production, like the drawings and to have some sort of input on, you know, the interactions that we have with professionals. I think that could kind of expedite that communicative process.
I see. Anyone else wants to add something?
I guess like if you're confused like in the beginning, like where to start and like specific points even before like, you know, reaching out to professionals, maybe, you know, like take a look at all the previous construction drawings like Solar Decathlon. You can see all the construction drawings from previous teams on there, and that really helped me out as well. So like in terms of like where to begin, like how to like direct anything like, you know, your submissions or construction drawings, I think that's a good place to start as well.
Yeah, I think that's a really good piece of advice. Like having some reference to work with, that how many drawings the student should produce, what should be the elements indicated in those drawings could be really helpful.
My last thing, sorry if anyone else was planning on going. My last thing was my advice to future students is to trust yourselves more with the design you create. For example, there was just a lot of uncertainty when we would send our designs to professionals, and a lot of worry of whether or not it would work. The thing is, if something was horribly wrong with our design, professionals would notice it immediately. So if you send it to them and they don't, you know, point out anything horribly wrong, then you should trust your design and move forward with it.
Yeah, I think I can relate to that, because like for many of the systems, students are doing it for the first time and they are worried whether it's code compliant or what if something happens once the house is constructed. So like believing in yourself because is a very big thing. Cool. Lauren or Hussein, if you have anything to add.
Yeah, in our case, we must believe in us. We finished 3 participants, and we must to make anything, and building construction. Oh no, an enterprise. I don't know how you say the enterprise. Well, an enterprise must to build our house because the government puts donate us subsidies. So we must only just follow the process. But we must to say that how to make a change in the house, and we must to talk with the people that was build the house, and all the process we must be there always, and we must to give an order to change something that was very bad. We must to say that only because it's our project, and we designed this house. We changed 3 times this house, just the interior, because we have sorry, we have a grid, and we must to change the interiors, all interiors, three times, for because well, we have a problem. I yesterday saw that, or Nina mentioned that, but the most important is the force, and believe in us. Oh, say, please, maybe I'm sorry.
Yeah, you got it right, Chris.
Yeah.
Yeah.
Yeah, and work hard, and doesn't matter if we have a mistake, doesn't matter, or in the paper, but in the construction we must to follow the process always. I will be an architect in 3 months more, and I'm very nervous for that. But in this project and project past in construction, teach me that we must always comprobate ever and calculate the items, calculate the materials 2 and 3 and 4 times before to lend, yes, to lend the materials, because if it's not enough, you have the consequence. The money is very important. We must take care of the money.
I see. All right. So my concluding thoughts for this session is, from my experience, like there will be times in this project where things won't move, where there are a lot of problems, and you will doubt yourself. But never giving up is an ability you will definitely develop in this project. And finding, instead of like analyzing the situation that these are the problems, always have like 2 or 3 backup plans. If this doesn't work out, we'll approach this way. If a particular design mentor is not responding and we need to submit drawings in a week, maybe ask professor or maybe have another design mentor to get things moving. And taking risk is a big part. I like going into profession, you might not easily get such opportunities to do this kind of innovations. So using this project as a way where all your vision gets into the reality and working hard. And I have seen you might have some time where you will be sacrificing few things for the project, but in the long run you will realize that you learned a lot and it was all worth it at the end of the project. Uh, so a last piece of advice would be thinking long term and taking risk to make a change in the society will definitely make you proud. All right, so I think that's it for the night. Tomorrow we'll have a detailed discussion on the construction aspect of the house, and day after tomorrow it's project management and fundraising. So thanks a lot, guys, for joining this call. It was an amazing discussion. I learned a lot. See you. Good night.
Thank you.
Thank you.
Yeah.
Bye bye.
Bye bye.